But what CERN did was split a singularity, and for 0.003 seconds. The rules of reality changed. Gravity warped. Information leaked, and the universe might never forget what we did. In 2023, at the Large Hadron Collider, scientists pushed beyond the God particle. CERN's upgraded collider reached energies that theoretical physicists once deemed impossible. For the first time in human history, researchers didn't just create a quantum singularity, they split one. What happened next shocked even the most seasoned quantum physicists. The detector chamber experienced radiation levels never before recorded. Emergency systems triggered automatically. And then silence. Data showed something unprecedented had occurred. The singularity divided into two separate entities, each emitting Hawking radiation at intensities that overwhelmed the most advanced sensors on Earth. But that wasn't what terrified the researchers. It was what they found in the aftermath. The split created something that shouldn't exist. A momentary tear in the fabric of spacetime itself. Did CERN accidentally punch a hole through the membrane of our reality? And more importantly, what might have glimpsed back through that hole? Stay with me. The truth is more incredible than you can imagine. The incident they never planned. The test wasn't public. Not even most of the CERN staff knew, but in a high-energy after-hours configuration of the collider, something appeared. A microscopic singularity, hot, rapidly decaying. Then it split. Not a collision, not a decay, a vision of the unbreakable. This was something new, not theorized, not predicted. And that's when they realized the data wasn't just surprising. It was impossible. The team had been pushing the Large Hadron Collider beyond its designed capacity. Only a skeleton crew remained when detector readings spiked to levels never before recorded. We initially thought it was an equipment malfunction, explained Dr. Thomas Henriksen, a lead physicist at CERN. The energy signature didn't match anything in our models. What they created was a quantum black hole smaller than a proton. Something that should evaporate via Hawking radiation in less than a billionth of a second. But it didn't just evaporate. It divided. The team watched in real time as their detectors registered not one, but two distinct energy signatures, each one radiating with half the mass of the original singularity, but with double the intensity. The control room footage shows researchers frantically working to contain the unexpected reaction. Emergency protocols activated automatically as radiation levels spiked. In those fractions of a second, the detector chamber experienced temperatures approaching those of the early universe. Material components began to melt and warp under the intense energy release. But what has physicists truly baffled isn't the equipment damage. It's the data itself. What happened in that chamber defies our understanding of quantum mechanics and general relativity. The laws of physics shouldn't allow a singularity to split. So what does it mean when the impossible happens? And why are theoretical physicists now scrambling to explain a phenomenon that, according to everything we know about the universe, should never have occurred? You don't just split a singularity. It's like tearing the fabric of space-time twice. If the original was a locked door, this was forcing it open from both ends. They didn't know what was behind it, and for a moment, they saw it anyway. Think of it this way. A black hole is already nature's most extreme object. It's where the laws of physics break down completely. At its center lies what we call a singularity, a point of infinite density where space and time cease to exist as we understand them. What CERN did was create a microscopic version of this cosmic monster. But instead of letting it evaporate naturally, they witnessed it do something that should be theoretically impossible. The singularity split, divided, tore itself in two. Imagine taking the most fundamental building block of reality and cutting it in half. That's what happened in that chamber. The data shows that for a fraction of a second, the quantum properties of the surrounding space changed. Gravity didn't behave according to Einstein's equations. The vacuum itself seemed to fluctuate as if the constants of nature were momentarily rewritten. When you punch through the fabric of reality once, you're breaking the rules. When you tear it twice simultaneously, you're creating a window between realities. The researchers reported something extraordinary in those milliseconds, a radiation signature that couldn't be explained by standard particle physics. It was as if information from somewhere else briefly leaked through. This wasn't just another particle discovery. This was humans tampering with the fundamental code of the universe itself. And we have no idea what we noticed. Got it? I'll continue formatting the next portion into clean paragraphs, keeping every single word intact. What escaped the split? After the split, radiation signatures spiked, but not randomly. The patterns were structured like interference, like something echoing from inside. Some physicists now believe it was a brief quantum feedback loop where the energy from the split began feeding back into the vacuum field. A loop, a self-sustaining cycle until it collapsed in on itself. But before it did, one thing became clear. The information inside the black hole didn't stay inside. The data collected during those crucial milliseconds shows something that's sending shock waves through the scientific community. The radiation wasn't just intense, it was organized. "We've never seen anything like it," said Dr. Elena Costes from MIT's Quantum Physics Department. The emission pattern had a structure that suggests information transfer. This directly challenges what we thought we knew about black holes. According to Stephen Hawking's theories, information that falls into a black hole should be permanently trapped or scrambled beyond recognition. Yet, the split singularity appeared to leak information in a coherent pattern. The detector readings revealed pulses that repeated with mathematical precision, almost like a signal or a code. It's as if the vacuum itself began resonating, explains theoretical physicist Dr. Richard Hammond. The energy output from one split fed back into the other, creating a self-amplifying cascade. This quantum feedback loop generated waves of gravitational distortion that temporarily altered the properties of space around the experiment. For those brief moments, the fundamental constants that govern our reality, the strength of forces, the behavior of fields, fluctuated measurably. Equipment in the chamber recorded unexplained electromagnetic anomalies. Computers crashed. Monitoring systems registered what one researcher described as reality glitches. The most disturbing possibility, that the split singularity momentarily connected our universe to something else, another dimension, a parallel reality, or something even more alien to our understanding. Whatever it was, the data suggests something escaped. Information leaked across a boundary that should have been impenetrable. And if information can leak out, what might leak in? The warning in the data. The energy profile didn't match any standard decay. Instead, the waveform mirrored patterns seen in early universe simulations, inflation-era radiation, which led to the question no one wanted to ask. Had they created a localized Big Bang? And if so, had they done it inside our own? When CERN's top analysts processed the full data set weeks later, they discovered something that changed everything. The radiation signature from the split singularity didn't match any known particle decay pattern. What it did match was something far more unsettling. The frequency distribution was eerily similar to what our models predict for the cosmic microwave background radiation during the inflation period of the early universe, explains cosmologist Dr. Sarah Hernandez. This isn't just unusual, it's paradigm shifting. The cosmic microwave background is the afterglow of the Big Bang itself, the oldest light in our universe. It has a very specific pattern that cosmologists have mapped in exquisite detail. For a man-made experiment to produce radiation with matching characteristics suggests something profound occurred in that detector chamber. In essence, the split singularity may have briefly recreated conditions that existed when our universe was less than a trillionth of a second old. A miniature Big Bang. The implications stagger the mind. If splitting a quantum singularity creates a localized expansion point similar to cosmic inflation, we may have temporarily generated a bubble of new space-time within our existing universe. The mathematics suggests a pocket of altered vacuum state, notes theoretical physicist Dr. Marcus Liu. For a fraction of a second, the fundamental constants in that region may have been completely different from our own. This raises profound questions about the nature of our cosmos. Could our entire universe be the result of a similar event in some larger reality? Are we living inside what amounts to a cosmic-scale version of CERN's experiment? And most troubling of all, if splitting a singularity creates a new expansion point, what happens if that expansion doesn't stop?